Hello, everyone.
Good evening, ma'am.
Yeah, good evening.
Good evening.
So this is your doubt session for week 5. So you can start asking your doubt. I
Ma'am,
will
I have
start
a
with
doubt. Activity
activity
5.3,
5.
question number 1.
Okay. Anyone has any doubt from 5.1? Yeah, 5.3 which question?
First, one.
Question number 1. Okay.
Yes, ma'am.
So the question is, in how many ways can a test paper of 6 questions be attempted? Each questions be true or false type. Okay. So first of all, how did you approach this question?
I am trying to solve like 2 to the power 6. Like,
Okay, so we have two things, true or false, or maybe we can skip the question also, right? Because it is not written that all the questions are compulsory. Okay, so the question is that in how many ways can a paper of 6 question can be attempted? Okay, so maybe there is a possibility that we are not attempting all the 6 questions. Like we can skip one question and maybe in second question we are filling true, and in other question we are filling false, and we are skipping the fourth question, maybe like that. Okay, so in a paper which contains 6 questions, so for each question we can have three possibilities: true, false, or we are not answering the question. So it will become 3 to the power 6. Okay.
okay, ma'am.
Yeah, any other question?
Ma'am,
Hmm.
ma'am, I have a small doubt regarding AMQ. Can I ask it now?
EMQ, okay, what?
Ma'am, how to submit that zip file and what comes after test run? Ma'am, I don't know that. I'm not familiar with that.
Okay, so instructions are given there, I think. You can read that. Did you check that?
Yes, ma'am. Here written press test run. So I don't know what comes after test run. Ma'am, after pressing that test run, can we have to submit or we have to check something else?
You have to submit the zip file of your answer. I think that's it.
Okay, ma'am.
I was uploaded in TXT format. Like,
Yeah, whatever instructions are given, you have to submit according to that. Okay, any other doubt from any other activity or any question
Oh, ma'am.
from this seat? Anyone else? Have you all tried solving all the questions?
No, ma'am.
So why did you not try? You should have tried at least. So no one has any doubt?
No, ma'am. I have, but what is like we will be solving this activity 5.3?
No, I am not solving all the questions. If you have tried solving the questions and you're getting stuck in any of the questions, then you can ask me.
Ma'am, I
I
have
have
doubt in the last question.
This question number 4.
Yes, ma'am.
Okay. So the question is, in how many ways can 5 distinct books be arranged in 2 bookshelves? Okay, so first of all, you tell me, how did you solve?
Actually, I'm not getting that how to start in this question, because I thought of that if the books are to be given in 2 bookshelves, so there are 2 ways for all the 5 books to go, but not getting how to start it.
Okay, anyone else has solved this question?
Yes.
No, no.
I was
Okay,
solved, but
yeah.
like we have two shelves. We can put 3 books and 2 books, 2 books, 3 books, 1 books, 4 books, like that. So this
Yes, yes.
approach I have tried, and answer gets 720.
Yeah, it's correct. Okay, I'll explain it now. So we have 5 distinct books, and we have to arrange them in 5 into bookshelf. Okay. So suppose if I draw it roughly, suppose these are 2 bookshelves. Okay, so this is your first bookshelf and this is your second bookshelf. Okay, you have 5 different books. Okay, so you have, suppose, B1, B2, B3, B4, and B5. Okay, so out of the 5 different books, you have to select the books. Okay, like which of the books will be going into shelf 1 and which of the books will be going to shelf 2, and how many books will be going to shelf 1 and how many books will be going to shelf 2. Okay, so there can be multiple ways. So I will write all the possibilities. So suppose for the first bookshelf, okay, so maybe you are keeping 1 book only here. Okay, so you have to select 1 book out of these 5 books, right? So that we can do it. So 5P1 ways, right? We have to select the book and we have to arrange it also. So we are taking 1 book only, so arrangement does not does not really matter. So
Yes.
now if we have kept 1 book in the shelf number 1, now we are left with only 4 books, right? So remaining 4 books we can keep here in the shelf number 2. So now we have to arrange 4 books here. So that, how can we do? In how many ways?
5
4P,
ways, I think.
It will be 4
4P,
it will simply be 4 factorial. Okay, because out of the 5 books you have selected 1 book, so that we can do it 5 ways, right? 5 ways will be there. This 5P1 is equal to 5, right?
Yes.
Okay, now we are left with 4 books. So whatever 4 books you have to arrange them. Okay, so that you can do it 4 factorial ways. Now suppose you are keeping 2 books in the shelf number 1 and you have to arrange them also, so that you can do it 5P2 ways, right? So out of
yes,
the 5 books, you are selecting 2 books and you are arranging them here. Okay, so that we can do it 5P2 ways. Okay, now we are left with 3 books, correct?
3 factorial.
Yeah, so we have to arrange the remaining 3 books, that we can do in 3 factorial ways. Okay, similarly, we can select 3 books and arrange them in the shelf number 1, and then we will be left with only 2 books that we have to arrange here in shelf number 2. Similarly, we are selecting 4 and arranging them here. So here we will be left with only 1 book. Okay, then we are taking all the 5 books here, and here we are not keeping any of the book. So it will be 0 factorial. Okay, or maybe we are keeping all the 5 books here, and like in the shelf number 2, and in the shelf number 1 we are not taking any of the book, right? So here it will be like you have 5 books that you have to arrange. So what will come here? 5 factorial.
0.
Yes.
Okay. You have 5 books which you have to arrange in shelf number 2. Okay, so that
Any
we can do in 5
for
factorial ways. Sorry.
any easy way for this?
Yes, I'll explain. I will give you another perspective also for this question. Let's solve with this method and then I'll explain you. Okay. So now we will take all the possibilities. We have to add it, right? So this is one possibility, this one, this, and we have 6 possibilities, like 6 kind of arrangement. So now we will put the value of each. So this is 5 into 4 factorial, right? Then we have 5p2, okay? 5p2 into 3 factorial plus 5p3 into 2 factorial plus 5p4 into 1 factorial. Then we have 5p5 into 0 factorial plus 5p0 into 5 factorial. Now tell me the value of this.
Ma'am, either 5p2 is 3 factorial, na?
5p2.
Is it 3 factorial?
5p2 will be 5 factorial divided by 3 factorial. Okay. So this is actually 5 into 4 factorial. Okay.
All of them will be 5 factorial.
Yeah. So if you solve, then all that each step, each value will be 5 factorial. So do you all understand? Or should I solve it? So 5p2 is 5 factorial divided by 5 minus 2, which is 3 factorial. And then it will be 3 factorial. Okay. Similarly, 5p3 will be 5 factorial divided by 2 factorial into 2 factorial. Similarly, this will be 5 factorial. Okay. Into 1 factorial. Okay. And these two will also be 5 factorial. Okay. So now you can solve it and you will get that it is 6 into 5 factorial actually. 6 into 5 factorial is what? 6 factorial. So this will be 720. Is this thing clear to everyone?
Yes, ma'am. I think this method earlier was told, easiest method is also told.
Okay. So you can follow that method if you know. Okay. Or you can think of it like this, that suppose you have 5 books, B1, B2, B3, B4, and B5. Okay. So in how many ways you can arrange 5 things?
5 factorial.
5 factorial ways,
No,
right?
picture.
So this we can do in 5 factorial ways. Now, suppose this is one arrangement. Okay. So you have to arrange this thing in 2 bookshelves. So that I can write that this is bookshelf first, this is second. So I can write that B1 is here. Okay, suppose I am not keeping any book here. This is blank. So then B1, B2, B3, B4, and B5. Okay. Or maybe I can write B1 here and B2, B3, B4, B5. Or maybe B1, B2, B3, B4, and B5. Like this. And B4 and B5, and then all the books will come here, B1, B2, B3, B4, and B5, and here we have no books. So now you can see that we have 6 possibilities, right? 6 possibilities for all the arrangements. Like B1, B2, B3, B4 is one kind of arrangement. Or you can take like B2, B1, B3, B5, and B4. Suppose this is one arrangement. Now you have to arrange this thing in two bookshelf. Okay. So again, you can arrange this thing in 6 ways. So suppose I'm not putting any book here, then it will come like this: B2, B1, B3, B5, and B4. Okay. Now I am keeping B2 here, and then B1, B3, B5, and B4, like this. Now are you able to understand? Okay. So for 5 objects, you have 5 factorial ways to arrange it. Okay. But here there is one more condition, that you have to arrange them in in 2 different bookshelves. So that we can do in 6 ways. Okay. So for each arrangement, you have 6 possibilities. So you have to multiply it with 6. Okay. So either you can understand it like this, or you can solve it like this. Okay, both will give the same answer. You can see. Are you able to get the point? No one is able to understand the question?
Yes, ma'am, got it.
It's clear, ma'am.
Is it clear to everyone, or you can ask me again?
No, it's clear.
Okay. Okay, then what is the next question you want to ask?
Ma'am, will you take right now the doubts of practice assignment also?
Yeah, I will take that also. Just ask me the other question if you have any doubt.
Ma'am, when the question asks how many ways can we do this thing, then we do like NCR into R factorial. That is equal to NPR, right?
Yes, yes.
Okay.
Ma'am, if bookshelf was to be put in 3 shelves, then
Okay. So then there will be one more condition will be given.
getting
So
5,
suppose we are keeping one book.
we are getting 6 factorial.
What?
So in this, if we wanting,
Hmm.
yes, so if 3 shelves are there, then so we will add one more factorial or delete one more factorial. Just a little bit, matlab answer only in quick sense, not a deep sense.
Okay, so again, in this way, you will have to see for the third shelf also.
Yes, yes. So what will be the answer?
That I will have to calculate. I cannot say the answer directly. So there will be, right? Like we are keeping only one book here, then maybe we are selecting books here, and then we are taking two books here, like, or maybe two, then one here and two here. Okay. So in this way, we will have to take all the possibilities. So it will be a long question in that case. So maybe in those kind of question, one more condition, like few more conditions will be given. Otherwise, it will become very lengthy because so many possibilities can be there, right?
Okay, ma'am.
Hmm. Here we have only two books, so that is having less number of cases. If you
There
have
will be
3 bookshelves, then it will have more number of books. Sorry?
very long question.
Yes, yes, it will become very long. Is there other question from any other activity?
Ma'am, I have one question in practice assignment 5.
So did you check the solution? Because for practice assignment, solutions are also given. Which question you want to ask?
Ma'am, there are the question 4th is very tough.
Question number 4.
Yes, ma'am.
So suppose there are N1 doors to enter a stadium and N2 doors to exit the stadium. One can enter the stadium through any of the entry gate and exit from an exit gate only. Okay. In an experiment, let the outcomes be the gate of entry and gate of exit. Then what will be the cardinality of the sample space? So first of all, cardinality of sample space, meaning how many number of items will be there or how many elements will be there in your sample space. Okay. So that is denoted by the cardinality word. Okay. So here we have N1 doors for entry and N2 doors for exit. So simply it will be N1 into N2. Okay. Suppose you have N1 number of gates, or let's suppose the value of N1 is suppose 3. Okay. And suppose N2 is 2. Okay. So which means that you have 3 gates for entry and 2 gates for exit. Okay. So suppose gate number 1, gate number 2, and gate number 3. Okay. These are for entry. Okay. Now, if you
Got
enter
the answer.
with gate number 1, you have 2 options, right? You have 2 gate for exit. Okay. So it will be like for this gate, you have 2 options. Gate number 1 for exit and gate number 2 for exit. Okay. Similarly for this. So it will simply be 3 into 2. Now is that
Yes,
clear?
yes, ma'am. One more question.
Yes.
There was a diagram question at that is question number 19 is also, but that is not a diagram question was there, na, at 27th.
Yeah. So the question is 8 girls were playing a game during which they decided to sit around in 2 concentric circles as shown in the figure. So 4 out of them will sit on the inner circle and the remaining 4 will sit on the outer circle. So in how many ways can they occupy their places if Priya, who is the game master, has to sit in the outer circle? Okay, so in total we have 8 girls. And there is one condition that Priya will be sitting in the outer circle. Right? Okay. So you have to like from the remaining 7 girls, okay, because Priya position for Priya is already fixed. So from the remaining 7 girls, you have to select 4 girls, okay, for the inner circle. Okay, so that will be 7C4. Okay, then you have to arrange. Then you have to arrange them in a circular fashion, right? So you have 4 girls which you have to arrange in a circular fashion. So in how many ways can you do that?
4 factorial.
It will be 3 factorial. See, it is written here. You can see. Okay. So number of ways to choose the girl from the inner circle is 3 factorial, because you have 4 girls, okay, which you have to arrange in the inner circle, like in a circular fashion. So that you can do in 3 factorial ways, right? We studied this thing yesterday, that if you have to arrange n objects according to a circular fashion, that we can do in n minus 1 factorial ways. Is this thing clear up to this point? Yes, no?
Yes, ma'am.
Yes, ma'am.
So we have done, so we have arranged the girls for the inner circle, right? Then we have to arrange the girls for the outer circle as well. Okay. Now there is one thing to see, that we have 2 circles here. Okay. You have arranged 4 girls in the inner circle, suppose. Okay. Suppose this is girl number 1, this is 2, this is 3, and this is 4. Okay. Now, if you are arranging the remaining 4 girls for the outer circle, then actually it will be happening according to a linear fashion. Okay. Because suppose if I write like
Is
this,
linear fashion.
so for outer circle, you have to arrange the 4 girls in linear fashion. Okay. Why? That's what I am explaining. Suppose this is one arrangement. Okay. Now, if you see this thing, okay, this is G1 again, G2, G3, and G4. Okay, same as I have written here. Now I will do it for the outer circle. Okay, so suppose I'm writing it here. This is O1, O2, O3, and O4. Okay, so now you can see that in these 2 cases, arrangement of the girls are different, right? If you look that behind this girl G1, O4 is sitting. But in this, behind this girl G1, O1 is sitting. Right? Do you agree with this point?
Ma'am, I don't get it.
So basically, the person sitting behind the
We are,
reference will be 4 different,
we
so
are
4 into
reversing
3
that.
factorial. Is that the right way? Because
Okay.
the arrangement of the outer circle can be 3 factorial, but then the reference will shift to 4 people. So it becomes 4 factorial.
Okay, we are fixing G1.
See, okay, see, basically we have to arrange the girls in the circular fashion. Okay. So in the inner circle, we have already arranged it, that we can do in 3 factorial ways, right? To this point, is it clear?
Yes.
Ma'am, 3 factorial, if 4 girls has to be arranged in a
In
circular,
circular,
so n minus r, na?
n minus 1, not n minus r.
Okay, ma'am.
Okay, so if you have 4 elements, 4 objects to arrange in a circular fashion, that will be 4 minus 1 factorial ways to arrange them according to a circular table. Okay, so that's how it is 3 factorial. Now you can think of that again, we have to arrange 4 girls for the outer circle. Okay, so someone can assume that that will also be happening in 3 factorial ways, but that will actually be wrong. Why? Because you can see that in these 2 cases, okay, just look at these 2 diagrams. Okay, so in yesterday's session, I told you that in circular, when you arrange the things in circular fashion, then A, B, C, D. Okay, this is same as A, B, C, D. Is that clear to you?
Yes, ma'am.
Yes.
Okay, because we are just rotating them. So that's why these 2 were same. Here also you can see that what I have done. O1, then O2, O3, O4, and then O1. So here also I have written the same thing. O1, O2, O3, and O4. Okay. So if I arrange them, like if you arrange them circular fashion, okay, so that will actually be wrong, because you can see those 2 arrangements are actually different. Okay,
With
now
respect to the inner circle.
yeah, with respect to the inner circle, these arrangement will actually be different. Okay, so actually we have to arrange them in a linear fashion instead of arranging them according to a circular table.
Okay,
Okay,
ma'am.
so that's why, yeah, so that's why for arranging the girls, 4 girls for outer circle, that will be 4 factorial ways.
Because the
Okay,
reference
if you
goes to
have
the
to
inner
arrange n
circle.
objects,
That is why it's 4 factorial. Not the
yes,
outer
yes.
circle. The
Okay,
reference
because
has
we
gone
have,
inside. Got it.
yes, yes.
मैम वो जो 7 CR वाला था वो वाला भी नहीं आया था समझ, जो वहां पे एंड वाले तो दोनों आ गए, आउटर और इनर वाले, उसमें एक स्टार्टिंग में भी कुछ लिखा था ना।
Yes, yes. Okay, see, here it is given that Priya is some girl who is the game master, so she has to sit on the outer circle. Okay, so like we have already selected one girl. Suppose this one girl is Priya, and she has to sit in the outer circle. Okay, so what we have to do? We had total 8 girls, right? Out of those, we have already fixed the position for Priya, which is the outer circle. Now we have to select from the remaining 7 girls. Okay, we have to select 4 girls out of the remaining 7 girls for the inner circle. Okay, so that's what we are doing. So we are selecting 4 girls first for the inner circle, and then we have arranged them in the linear circle. Oh, sorry, in an inner circle, that will be 3 factorial, and then we will be arranging the remaining these 4 girls, Priya and the other 3 girls, in a linear fashion. So that we can do in 4 factorial ways.
Ma'am, if
So
question
this
is
will be
not,
the final answer.
then answer. If question does not say linear fashion, then
That is understood here. If you have
yes, ma'am.
two concentric circles, okay, then with respect to each other, the one will be having a linear arrangement.
Ma'am, but here in week 5, we were not being taught about combinations. Then too, here the question is given.
Yes, yes, that I agree. So the combination will come in week 6 actually. Can you skip the question for week 5, or then when you study week 6, then
Can
you
you
can
explain
again go back to
25th
this
question of this
question, solve it.
assignment?
And ma'am, the questions, the type of questions which were given to us in the activity questions, they were simpler, like we were able to solve it. But in practice questions, we are not able to predict and solve like how to start the questions.
Let's solve the 25th one.
The solution is also given so that it will be for you to understand the question. Okay, so question number 25 is, there are 30 students in our class who are supposed to be seated in 6 rows containing 6 seats each. In how many ways can they occupy seats if 2 students A and B are asked to sit in the same room? Okay, so we have 6 rows. Okay, and all are having 6 seats, right? So in total, we have 6 into 6, 36 seats. Is this correct?
Yes, ma'am.
Is this clear? Okay, we have 6 rows and each row has 6 seats. So we have, in total, we have 36 seats. Okay, now there is condition that A and B are asked to sit in the same room. So suppose if A has to sit somewhere, okay. First of all, A has to sit somewhere. So A has 36 options, right? A has 6 into 6, 36 options to sit anywhere in these in this arrangement, right? Suppose A is sitting here, okay. Then the condition is that like A and B should be same room, okay. So if A is sitting here, then he should also sit in this row only, right? Maybe he can come here or here or here or in this row, anywhere in this row. Okay. So B has 5 options to sit, right? The remaining 5 seats in the row. Is this clear?
Ma'am, your voice was breaking.
Yes, ma'am, your voice is breaking.
Yes, voice is breaking.
Okay, 1 minute.
And screen is also like hanging in between.
Hello. Is it better now?
No, ma'am,
No, ma'am, still
still
breaking.
breaking.
Okay, ma'am, we can.
Okay. Okay, so is it clear to this point?
B sitting issue.
Okay. So, okay, first of all, A can sit anywhere in this 36 seats. Is this clear?
Yes, ma'am.
Okay. Now the condition is that B should sit in the same row. Right? A and B are sitting in the same row. So according to this condition, B can sit like here or anywhere in this row, right? So B has 5 options. Now is this clear?
Yes, ma'am.
B can come anywhere in this row. So B will have 5 options to sit. Okay. Suppose B is sitting here. Okay. Now, how many seats we are left with? 34, right? 2 seats are occupied by A and B. So now we are left with 34 seats. Is that clear?
Yes, ma'am.
Okay. So 34 seats are left, and in total we have 30 students. Okay. So out of the 30 students, we have arranged A and B. Okay, A and B got the seat. So now we are left with 28 students. Okay. So these 34 seats, in that we can arrange 28 students. Okay. So this we have to multiply here. Okay. So what we
Okay.
have done, in total we had 36 seats. Okay. So first we got the seat for A. Okay. So that we can do in 6 into 6, 36 seats. Now B has to sit in the same row. So B can have only 5 possibilities. Okay. And then we have to arrange the remaining 28 students in the remaining 34 seats. Okay. So that we can do in 34 P28 ways. Okay. So if you multiply all these 3 things, you will get the final answer.
Ma'am, the question asked A and B can sit in same row. So it should be 1 5 more now because A can be also sit in fives.
What?
Like you said that B has 5 options to sit, right?
Yes.
Also A can be sit in 5 ways because A and B have to be seated in the same row.
See, okay. Suppose you two people are going somewhere, you have 36 seats. Okay, like this. You have to sit together and anywhere in these 36 seats. So how will you choose? Okay. So first of all, any one of them will sit anywhere on these 36 seats, right? So
Yeah,
first of
ma'am.
all, you have 36 options, right? First of all, you have 36 options. Now, if you select one seat, suppose anywhere here, suppose here, okay? Now the condition is that both person has to sit in the same row. So then the next person can have only 5 number of possibilities.
Because your row gets fixed, you have only the seats in that row you will select. That's why
Question number 21 is also tough.
Okay, first of all, this question is clear.
Yes, ma'am, this is very much clear.
Okay, next question number 21. Okay. So the question is, an Alzheimer patient has to take medication twice a day. She needs to take one blue and one black pill in the morning, one green and one yellow pill in the afternoon, and one blue and one black pill in the evening. She doesn't know what color pills to take, but knows that she needs to take two pills, different color each time. So assume that there are infinite number of pills of each color. So in how many ways can she take the pills in a day? Order of taking the pills does not matter. That is, she can take first blue pill and later black pill in the morning, or okay, it's clear. So the thing is, so how many colors we have here in total? We have blue color pills, black color pills, right? Blue color, black color,
4 colors.
green color, and yellow color. So in total, we have 4 colors. Okay, black, blue, green, and yellow. Okay, so and she has to take 2 pills of different colors each time. Right? In the morning, she has to take 2 pills of different colors. In the evening, she has to take 2 pills of different color, and in the afternoon also. So what can we do here? That we can make combinations of these colors, right? So these combinations are written here. Okay, so actually we have to take like all the possibilities, okay, in which she can take the 2 different color pills. Okay, because she is having Alzheimer, so she will not taking the pills correctly. Okay, she has to take one blue and one black pill in the morning, but she doesn't remember this, so she can take any 2 pills of different color. Okay, so actually we have to see like how many combination we can have of 2 different color pills out of the 4 different colors. Okay, so that's why we have made these combinations. Is this in clear up to this point?
Yes.
Okay, so there are 6 possibilities in which she can take 2 pills. Okay, so these 6 possibilities are there for morning, same for afternoon, and same for evening. Right? So see, so there are 6 possibilities for all the 3 times. So it will be 6 into 6 into 6. Are you getting the point? Is this clear?
Yes, ma'am. Ma'am, can you explain question number 3?
Okay, is this anyone having any doubt in this question?
Oh, ma'am.
Question number 3. This one. Okay. So question is, suppose that number of runs scored off a delivery is uniform in 1, 2, 3, 4, 5, 6. Is independent of what happens in the other delivery. A batsman played 3 deliveries, then find the number of possible outcomes such that he hit 2 runs in at least 1 delivery. Okay, so the question is that a batsman is playing 3 deliveries. Okay, so in at least 1 delivery, he should hit 2 runs. Okay, So there can be three things, that maybe in only one delivery he is getting 2 runs, or maybe in 2 deliveries he is getting 2 runs, right? Or maybe in all the 3 deliveries he is getting 2 runs, right? Because it
Per
is given
delivery, he's getting 2 run.
what?
Per delivery, he's getting 2 run.
Okay. There can be 3 different conditions. So for 3 deliveries, it is given that the condition is he hit 2 runs in at least one delivery. At least one. Do you understand what is the meaning of at least one?
Minimum
One of the
2.
3 deliveries, minimum is put
It
2
is
runs in
minimum
one
case.
of the
Okay.
deliveries.
So it may be maybe in one delivery he's hitting 2 runs, or maybe in 2 deliveries he is hitting 2 runs, or maybe in the 3 deliveries he is getting 2 runs. Right? Is that clear? So 3 cases will be there. Okay. Now we will see that suppose the first case is in the like out of the 3, maybe so like out of the 3, in any of the 3 like any one of the 3 he can hit 2 runs, right?
Yes, ma'am.
Okay. So that how can we distribute it? So the number of runs is 1, 2, 3, 4, 5, 6. Okay. So suppose this is first, second, and third. Okay. So maybe he's hitting 2 runs in the first delivery. Okay. And then for the other 2 deliveries, he will get the run from 1, 3, 4, 5, and 6. Okay. Then similarly, it will be 1, 3, 4, 5, and 6. Okay. Or maybe in the second delivery, he is getting 2 runs. Okay. Then for the first delivery, it will be 1, 3, 4, 5, 6. Okay. He will hit the run out of these 5 possibilities. Okay. Or maybe okay, so this is the possibility if he is hitting the run in only one delivery. Okay. So now you can see that here we have only one possibility. So this is 1. For the second delivery, he has 5 possibilities, right? Then for the third delivery, he has 5 possibilities. Okay. Similarly, we can do it for here also.
5 into 1 into 5.
5 into 1 into 5. Then 5 into 5 into 1. Okay. So this is actually 3 into 25. Is this clear up to this point?
Yes, ma'am.
Okay.
3
So
into
this is done.
25.
Yeah, because it's either option 1, 2, or 3. So it becomes
Because
5 into
yeah.
5 added 3 times.
So maybe he can hit 2 runs in the first delivery, or maybe in the second delivery, or maybe in the third delivery. Okay.
Yes.
So there are 3 possibilities for each case.
Yes, ma'am. Got it.
Okay. So this happens when he is hitting 2 runs only in the one delivery. Now there will be another case when he will hit 2 runs in 2 of the deliveries. Okay, that you can see in the case 2, that he is hitting 2 runs in 2 of the deliveries. So that you can see.
We will have 3 cases into 5.
Again, we will have 3 cases. So how they are distributed. So suppose 2 runs, and here he can have 1, 3, 4, 5, and 6, right? Or maybe 1, 3, 4, 5, 6 here, and then 2 runs and 2 runs. Okay. Or maybe it is distributed like this, 2 runs, and in the second delivery he is getting runs out of 1, 3, 4, 5, and 6, and 2 runs. Okay, so here also you can see that for the first position, for the first delivery, number of possibilities one only. For the second delivery, number of possibilities one only. And for the third delivery, we have 5 possibilities. Okay. Similarly, for the next case,
3 into 5.
okay, so it will be 5 into 3. Okay. Similarly, for the there will be one more case when in all the 3 deliveries he is making 2 runs. So that will only be one case, right? In all the 3 deliveries,
Yes.
okay, he is making 2 runs. Okay, so this is only one possibility. Okay, so in total, how many we will have? 25 into 3 plus 5 into 3 plus 1.
15.
25 plus 15 plus 1.
91.
Okay, so this will be equal to 91. Okay, you can check the answer also here.
Yes,
Is this
ma'am.
question clear?
Yes, ma'am.
Yeah, what next? Any other question?
Ma'am, question number 5.
So question number 5 is Prakash is going to assemble a laptop by himself. He has the choice of chips from Intel, Motorola, uh, NVIDIA, and this Qualcomm. Hard drive from 4 brands, memory from 7 brands, and accessories bundle from 10 local stores. So how many different ways can Prakash order the parts? Assume he orders only one item from each category. So like simply you have to multiply for all the possibilities. Okay. So for chips, we have these 4 brands. Okay. For hard drive, we have 4 brands. For memory, we have 7 brands. And for, okay, and then that he can access bundle stores.
Accessories
Okay, so
from
again,
10 stores.
he has 10. Simply have to 4 into 4 into 7 into 10. Like simply you have to use the multiplication rule of counting.
Okay, ma'am. Got it.
Yes, anyone else having any doubt from any other activity? No one has any doubt now?
No, ma'am. Ma'am, so for this session, we have only not regarding 5th or up to 5th.
This is for week 5 only.
Only week 5.
Yes.
Ma'am, but here combinations are means
What?
there is one combination question, so combinations are to be मतलब हमें वो combination वाला part तो समझाया ही नहीं.
Yes, yes. So don't worry. You will study these things in week 6. Okay. Otherwise, I'll let you know the formula for combination. That is not so tough. So, okay. So this is the formula for combination. Okay. And what is the formula for permutation? NPR, this is n factorial divided by n minus r factorial. Okay. So in permutation, both the things are included. Both the things, which means you have to select the thing, select the items, and then you have to arrange. But in combination, you only have to select the items. Okay. Now, if you see the relation between these two things, so you can see that NCR is equal to 1 upon r factorial, n factorial upon n minus r factorial. Okay. Both are same. Okay. Now at the place of n factorial divided by n minus r factorial, I can write NPR. Is that correct?
Yes, ma'am.
Yes or no? Okay. So I can write NPR. Okay. This is NCR. Now this implies value of NPR is actually NCR multiplied by R factorial. Okay. So this is the relation between permutation and combination. Okay. Now I will again say this thing that permutation includes selection and arrangement. Okay. And combination only includes selection. So here you can see that this NCR helps you in selecting the objects. Okay. So this is for selection. And we saw that if you have n number of objects, or you can say r number of objects that you have to arrange. Okay, so if you have r number of objects which you have to arrange in linear fashion, how can you do that? In r factorial ways. Is that correct? If
Yes.
you have to arrange r objects, so in how many ways can we do that? R factorial ways, right? So this is for arrangement. So that's how this formula is made. Okay, so permutation includes both the things, selection and arrangement. Okay, that's why we say that when order matters, we use permutation. In combination, we have to do selection only. Okay.
But for formula for
Anything?
NPR is n factorial upon n minus r factorial भी right ना?
Yes, this is
नीचे
for
में r.
that's what I have solved here. Okay. NCR is what? NCR is equals to 1 upon r factorial into n factorial divided by n minus r factorial. This is the formula for combination. So here you can see this n factorial divided by n minus r factorial. This is the formula for permutation. That's why I have written NPR at this place. Okay. Now from here, if you calculate, okay, if you find the value of NPR, it will be NCR multiplied by r factorial.
Got it, ma'am.
Okay. Okay, so if you just remember this formula, then also you can use that. Okay. Yes, any other question? Anything else you want to ask?
Ma'am, seventh question of practice assignment.
Ma'am, if you don't mind, can you please once more tell the difference between, like, when should we use n minus 1 factorial for circular permutation and when n minus 1 factorial divided by 2? That difference, can you please tell?
Okay. So
Ma'am, we will take question, they will
Ma'am.
understand that.
yes, yes. So when clockwise and anti-clockwise are different, okay, then you have to use the formula n minus 1 factorial. And when clockwise and anti-clockwise are same, okay, when they both are same, then you have to use n minus 1 factorial divided by 2. Okay. Now you should be clear with what is the meaning of clockwise and anti-clockwise are different and same. Okay. So we discussed that suppose this is one arrangement of ABCD. So this is ABCD like this. Okay. And this is one arrangement. Okay. So if you look at both the graphs, like both the figures carefully, you can see that both are the like mirror image of each other. Okay. If you go
Yes, ma'am.
anti-clockwise, you will see A, B, then C, and then D, and then A. If you go anti-clockwise here, then it will be A, B, C, D, and then A. Okay. So when this clockwise and anti-clockwise does not matter. Okay. So let's take an example of beads. If you're making a bracelet or a necklace, okay, where you have beads of, you have to arrange beads. Okay. So you can flip this, right? You can flip this necklace or bracelet. Still that bracelet or necklace will be the same. Okay. So that clockwise and anti-clockwise will not be making any effect. Okay. So in those
Yes,
cases,
ma'am.
we say that clockwise and anti-clockwise are same, and then you have to use this formula. Okay.
Ma'am,
Otherwise,
if
when
we
they
are
both are
using this,
different,
yes, ma'am, if we are using this per person, then
yeah, for person it will be a like different arrangement,
okay, ma'am.
right? Because for person you can distinguish them.
Okay.
Okay, and you cannot flip the table or something, right? So these
Yes,
two
ma'am.
arrangement would be different. Yeah, so in
Understood,
that case,
ma'am.
you have to take n minus 1 factorial. Yeah, so if there is
Okay.
any question from activity or practice assignment, you can ask.
Ma'am, question 7 of practice assignment.
So the question is find the ratio of number of 3 digits, all digits being even, whose digits either increases or decreases from left to right. To the numbers of 3-digit numbers, all digits being odd, whose digits either increase or decrease from right to left. Okay. So first of all, you have to like see what all the numbers are which fulfilling these conditions. Okay. So you make the set and then count the number of like how many total number of elements are there in the set and then divide. So this is the main thing which you have to do. So we can do. So we have to make a 3-digit number from the even digits. And condition is that if it is increasing or decreasing from left to right.
So,
Okay.
ma'am, you are trying to say that we have to like make the numbers.
Yes, yes, you will have to see what all numbers are there which fulfill this condition. Okay. So we have to take the digits, even digits. So 0, 2, 4, 6, and 8. And we have to make a 3-digit number. Okay. And the condition is from left to right. Okay. From left to right, it should be either decreasing or increasing, right? Yeah, this is the condition. So how will you make the numbers?
In this, then first digit cannot be 0 anytime, so we can exclude 0 here.
Yes, we can exclude 0. Okay, so if I take increasing case first, so it will be 2, 4, 6, then 2, 4, 8, then 2, 6, 8, right? And
Yes.
next can be 4, 6, 8. So this will be for increasing case, right? Then we have to see when from left to right, numbers are decreasing. So for decreasing, we can take
864,
864,
862.
862, 860. Okay, then 842, 840, then 820.
Yes.
Then we can have numbers from starting from 642, 640, 620. And then we can have 420 like this.
Yes.
Okay, so how many total numbers are there? 10 plus 4. So total 14 numbers are there. Okay, so
So in the
and you
similar
have to
way,
take,
we have to make by the odd digits also, right?
yes, so we have to take odd digits 1, 3, 5, 7, and 9. Okay, and again you have to make these kind of numbers. Okay, from left to right, either it should be decreasing or increasing.
Okay,
And
ma'am.
then you can count the numbers and then take the ratio. So here it is 14, and then you can take that number. Okay, whatever it is, then you have to divide 14 divided by whatever comes here. Okay, you can check from the given solution. All the numbers are written here, and you can check from here. What was the question number?
It was 7th, ma'am. I got it.
Yeah, this is okay.
Thank you, ma'am.
So yeah, you can see that the ratio is 14 by 20. Okay, so when you make that set, it will have 20 numbers. Yeah, anything else? Any other question?
Excuse me, ma'am.
Yes.
Ma'am, in this, why 402 is not taken?
402, because if you take 402, then it is not decreasing and it is not increasing also. Okay, there is the condition that whose digits either increases or decreases from left to right. Okay, so you can see that in these numbers are increasing, like 2, 4, then 6, right? And 2, 4, and 8, they are increasing. In this, you can see all the numbers are decreasing. If you see 402, then you can see 0 is less than 1, less than 4, but 2 is greater than 0.
Okay, ma'am.
So it is neither increasing direction or not decreasing, right? So it is not fulfilling the condition.
Okay. Thank you, ma'am.
Yes, any other question?
Ma'am, in the practice assignment, question number 8, there it's given that we have to find the n least value of n. So there we have to put the values by the options and then find the answer.
Okay, 1 minute, I'll see the question. Question number 8.
Yes.
Okay. Question is 2100 distinct n-digit numbers are to be formed using exactly the digits 1, 2, 3. Okay. So the smallest value of n for which this can be possible, repetition of the digits are allowed. Okay. So if you have to make n-digit number from this 3 digits, so it will be 3 to the power n, right?
Yes.
Is this thing clear? And which
Ma'am, your voice is breaking.
you have to so also the places we have 3 options. Now is that right? Hello.
Yes, ma'am.
Am I
Now
audible
it's
now?
clear. Yes, ma'am.
Okay. Yeah. So this will be 3 to the power n. Okay. Now it is given that we can form 2100 distinct n digits number are to be formed using these 3 digits. Okay. So this 3 to the power n will be less than or equal to 2100. Okay. So you can see that like for which value of n you will get this condition fulfilled. So from there you have to decide the value of n.
Okay.
Okay, you will have to be like, yeah, for what value of n this equation is getting satisfied. Any other question? Anyone else having any doubt?
Hello teacher, I have a question.
Yes.
After
Question?
after passing qualifier exam, what should we do next? If I take take like 2 subjects per term, and what are all the procedures?
You can ask these type of questions to support team. You can mail them, okay, and they will answer you.
Okay.
Anyone else having any conceptual doubt? If no one has any doubt, then we can end the class. Anyone want to ask anything?
No, ma'am, thank you.
Okay, then we can end the class now. Thank you, everyone.